Hello Internet, today we are going to be working on LINQ for Unity, alternatively a LINQ or a Unity shell. Basically what this allows you to do is run C# commands against your Unity scene, and the results of that are displayed in this list over on the right side here. I don't know where my mouse is, but yeah, all of this would be results. The intention of this is sort of as a debugging tool, so you can sort of in real time see what's happening in your scene. But it also gives you some really nice development tools. For example, if you want to move all of your light sources down by like half of a unit, for example, you can just do that really quickly just by selecting everything with a light on it and modifying its transform to move it down a bit. It makes it really easy to sort of just run scripts. So what we're going to be doing today is making a grid renderer. This is probably a very long process. I'm hoping to do it all in one video, but depending on how this goes, things might get cut up. But basically, things are rendered in a list, and that list is not great for things like meshes, which typically just don't fill the entire space. There's a bunch of unused space when we use meshes. It would be great if we could fill that. And so we're going to try to fill that as best as we can using a grid-based renderer, so we can actually render things side by side rather than just vertically. To give you an example of some of the uses for this accepts all C# commands. So any API or any code that you enter is going to work here. What that means is you can just type anything you want. If we want to move our camera up by 1, we can just do camera.main.transform.position plus equals vector3.up. And that's just going to move our camera up by 1. The first time takes a bit just to compile everything and set everything up for you. But there we go. We moved our camera up. We also moved our light up because that's parented. So everything just worked. We moved that back down. Those kind of scripts cannot be undone just as a side effect of how this is working. Unity can't record the operation unless you manually record that the transform is changing. There's no way for me to detect that you are doing this without going down a very deep rabbit hole that I'm just not going to. Some other things do work though. So this just gives us the result of that. So this gave us the final transform position of the camera after that translation. But what we can do is we can actually just grab the transform. Transform.property of. Property of is something that I created in one of our live streams. And we're just going to grab the position of this. So if we run this, that's not how you do that. We have to paste it into the actual command thing and run this. We now get our camera's position. So this actually is an editable field. So unlike the previous result, which just set something, this actually returns the field that's storing the position. And we can change that in real time and actually get new values. So this is actually changing our camera and just changing where it is in real time. This works in both directions. So if we change this in the inspector or in game, it would also update this UI. And so you would also see that here. We can also just select the camera using that button. So if I unselect it and just click this, we're going to select whatever object is attached to that. This is name-based. It's the best that I could come up with because not everything is going to have a reference back to whatever game object it's attached to. It just isn't always possible to do that. But whenever possible, we try to create a reference back. So those are some of the things. What we're really focusing on is this shared mesh. There's a rerun button here. We're just going to rerun that shared mesh query. This looks at our scene and finds all of the meshes used by mesh filters in our scene. So in this case, there is 3. There's a cube, a sphere, and a capsule. And we get all of those meshes right here. These are editable again. So we can change the sphere to be a cube if we want to and change it back. That all works. If we want to select all of these objects, for example, we can do that and then move all of them simultaneously because we just get an inspector. All of that works. The problem is this is kind of a waste of space. It'd be really cool if all of this was happening on one line. So instead of taking up most of my screen and screen real estate and kind of wasting all this empty space underneath there, it would be really cool if it just wasn't like that. If everything sort of lined up. So we had the capsule and then the cube and then the sphere in order that way. So that's what we're going to try to do. The way this all works is there is a series of renders that tell LINQ for Unity how to render specific data types. If it doesn't know what the data type is, it actually is going to look for Unity's custom editor for that type and use that editor. But that isn't always the case. Sometimes you want something custom for this tool, just because typically you're trying to inspect specific things. Let me see. I had some queries for this down here. Sorry, I've been testing things. So this one, if we grab colliders, I do not have any editor for, but this actually gives you something. So all of those are just the primitive types. They come with colliders attached to them. We can grab all those colliders and then show the editors, and this gives us all the inspector stuff for all those types. So we can actually just edit all of that here, and it will all reflect in your scene. So we can just hide that back. Yeah, that's the tool. I haven't shown it in video, so I'm kind of going through things and showing how this all works. It also is changing constantly. So in a week, it may look different than this or may behave differently. Still figuring out how best to make this useful. If you have suggestions or ideas, leave a comment, or maybe consider joining the live streams. We've been doing a lot of this work in live streams to kind of share in real time what's going on. And so you can always tune in there on twitch.tv/worldofzerodev. So we want a grid render. I've already done some of the work for this, mostly working on how to define the interface and how all of that will work. To get you caught up on all of that, everything is rendered here inside of this result renderer. So there's really one main type that's doing all of the rendering, and that's this iResult render, which is an interface defining something that renders a type. The way this tool detects things to draw is it actually goes and looks up every class in your assembly that implements this interface and figures out what the rendered type for those is. And based off of that, we are able to look up the proper renderer to use for the type that we're trying to render. So in this, if we're trying to render a position, we're going to look for something that supports a vector. So in this case, the vector 3 renderer, we're going to find this thing. Other things are going to be of different types. And we have things that are more generic to kind of overall catch like exceptions. So if any exception occurs, we have something to draw exceptions so that it's very easy to see like something broke. Here's information. Here's how to debug it. Like compile errors, for example, because it's all just C#. That's all done here. The things that I've added is this renderer type, which can either be list or grid. And there's now 2 functions here. There used to be just one, which was the render function. That's now refactored into render list, which will render the things in a list form, and render grid, which is going to render things in the grid format that we're doing. The difference is grid is going to accept a rectangle. So the renderer is actually going to pass in the rect area, like the boundary that grid cell can occupy. So it's going to need to be a little bit smarter than our current solution, because our current solution is really, really simple. It just says, draw all these things in order, just in a vertical list. This is going to require a little bit more thought. But this is basically how it works. You get a value in, and you return the new value. Just like Unity's normal UI, if you're creating other UI elements in Unity's UI, it just works. You can actually see that a lot of these renders are intentionally very small. In this case, we're rendering a vector 3. It's literally just running the vector 3 field editor. That's it. It's even just returning the result directly. Like these are intended to be very small because there's something that you can implement for your own types or your own classes just as part of using this tool. What we want is to go into these subtypes. That vector 3 render is actually implementing the list result render. These are wrapper types, sort of internal, that are intended to help you, so you do not need to implement that interface. This interface is dealing with objects. What the list result render and the grid result render are doing is actually rendering based on the type. They actually do the typecast for you. And this way you can actually just create a generic type, and the API is fairly coherent. It's fairly easy to understand. At least that's sort of the hope. It does all the typing for you, implements all the properties for you. All of that's just handled. So you just need to implement one method, and the types are already there for you. So no casting, no anything. It's just something in, something out. I've implemented the same thing for the grid render. It does the exact same thing, just for grids. So all of the magic currently is inside this execution result component. This is gross. I've mentioned this a few times, but most of this code is proof of concept stuff. We're still figuring out if this actually works. It seems to so far, but a big part of that was cutting corners and going really fast and trying to just get this thing working. And so some of these functions are kind of gross. This is like 3 if statements inside of a for each, inside of a try. It's not great, and it just keeps going. There's UI rendering mixed with logic. All of this stuff shouldn't be happening in like good code, because this is untestable. To the best of my ability, this is not something that I want to test. This is something that you break apart and say, I'm never touching that. This is fine though, because it works, and we're still working on figuring everything out. Part of the point here is to go fast, get a prototype, and test and work on the user experience and figure out what this tool is being used for, and then start developing those things. This grid render is a direct result of this going fast method, because I originally was just thinking everything should be a list. That's how we started. That's how this all worked. Working with the meshes and now thinking about like textures and things like that. Those don't really make sense as a list. They because they're typically square, it's just not going to fit as we expect, and it doesn't seem like it would be the best experience. So part of this is all coming from that. And if we try to do like a really good design, and we don't really know the features that we actually are going to end up shipping with, that good design probably isn't going to be very good for very long, because we're going to have to refactor a lot of this to move forward. That's one of the nice things about going fast. Your code doesn't need to be great when you're first starting off. This is kind of going into another lecture. We haven't even written anything yet, but your code does not need to be great when you're starting off. Typically what you're aiming for is to get something working, and get it into people's hands so that they can actually start working with this. In this case, it's my hands, but the idea is still the same. You want to actually see what the experience is, what the result of your thing is, before cementing it and making a really strong contract that you're expecting to adhere to. In this case, we're still figuring all that out, so we're adding things, blowing things away, refactoring things, doing all of that, and trying to go as fast as possible, just so we can have as much iteration as we can. Anyway, this is where we need to do all the stuff, but we're not going to do it here. All of that tangent and demo and everything was basically to say we're not going to do any of this. What we're going to do is completely implement something else. We're going to implement a grid render. I think this is the best way to do this, but I could be wrong. What I'm thinking that I want to do is have something to render grids and something to render lists, and things are going to get complicated. Part of the problem with this whole solution of doing grids and lists is you can get both. I didn't show this, but I can show this now. All right, I will once what is this? Oh, we copied that. That's gonna create a whole bunch of errors. Anyway, part of the issue is you can actually select multiple properties. So you could select, say, the mesh and the position of the transform in the same select. There's nothing preventing you from doing that. The problem with that is one of those we'd want to render as a list, and one of those we'd want to render as a grid. And there is no way to distinguish which is which. If we just try to do one, the other one doesn't implement the function. I've designed it so only one of the functions needs to be implemented, whichever your enum says. And so we can't render everything as one type. It needs to be either one thing or the other thing. So we need two different renders, one that supports lists and one that supports grids. And we need to be able to render both of those for the components that match. So that's sort of what we're approaching this as. This is going to be our grid renderer. I don't think we want to call it a render. A render is something else. We want to call this a grid view. Grid view is a good name. I copied this class just because I didn't want to go through the class creation thing, but we're going to get rid of all of this. There we go. There's all of the things gone. So this, I think, is going to be a static class. So let's just get that out of the way. If you're unfamiliar, static classes are classes which cannot be instantiated or they can't be constructed. So there's no constructor attached to this class. If you try to construct it, it's going to give you an error. That's what doing a static class is. And if you try to implement a method that is not static inside of it, it's going to throw an error as well. It's sort of a safety feature there. Just to sort of prevent you if you're saying this class should never be created, it's just to contain these functions. It should be a static class. So public void, we want to draw grid results of something. Things, this is weird, but I'm gonna rename this first. But things are weird in how I have this implemented. There is a, what did I even call it? There is a set of something. LINQ commands. LINQ commands are the execution. They contain this huge series of property assigners. Property assigners are my way of cheating Unity. There's two types of values that can exist in C#. One of them is the value that actually stores the value. So in this case, if you're talking about like an integer, for example, that actually, when you refer to that that reference in your code, like int 42 is some variable. When you actually look at that, the value is 42. But if we are talking about something else, if we're talking about, say, a class, that is a reference type, which means that the value stored in that variable is actually pointing to a pointer that points to this value stored over here. We, in order for this tool to work, need pointers. We need to know what's containing this. Otherwise, if we're looking at a position and we just get the value, because structs are also value types, which means they store the value. If you try to assign a struct to a new variable, it's going to copy all those values into that thing. It's not going to give you the same reference. And so we want to be able to copy that reference because we want to be able to make edits. If we didn't have the reference, we wouldn't be able to make edits. So we need these property assigners in order to be able to access the properties and fields of these like transforms and things to be able to actually edit positions and things like that. There was a whole thing about this. I spent way too long on this. It does a bunch of reflection behind the scenes to actually grab the field and property that you're looking at. That's why the property of function exists in the first place, so that you can get editable versions of things. Anyway, that was a really long thing. We're gonna say draw a list. All right. So how this is going to work? For each variable foo, we want component in our draw list. All right, so how this is going to work is we're going to do some magic. I think what we want is an int of height. Size. We'll call it a size. These are going to be square components. What I mean by that is they are going to be rectangular. The size is going to be the size of the thing. Why can't I figure out the name? Anyway, they're going to be the size of what we're drawing. What we want to do is get an area, because most of the other stuff is using GUI layouts, so it's going to automatically appear below whatever we do. We need a size to grab a specific size for our grid, but we don't actually know what can fit inside that grid. So we're going to have to do a little bit of fanciness to get this to work. Basically, we are going to draw a grid, but we're going to do it line by line. So we're going to create a line to draw our elements in. And then until we run out of space or we run out of elements, we're going to draw new things side by side. Basically grabbing a rectangle and saying draw here, and then passing that rectangle to something else and saying draw here, and so forth. Eventually we're going to get to the end of the thing and need to go to the next line. We need to create a new line effectively and draw that. So this is going to be our var drawable line equals GUI layout. I believe we want editor GUI layout. And we want to get the control rectangle. What this is going to do is, for a specific set of layout options, it is going to grab a rectangle for you. What we want here is to grab a rectangle that we can actually draw our stuff in. So how do we want to do this? Drawable. Sorry, I already thought about this. I kind of have an idea about how I want to approach this. We're going to give it a size of height and a GUI layout of expand width. Set that to true. What I'm hoping this is going to do, I don't actually know. I haven't tested this. I don't know what's going to happen. What I'm hoping this is going to do is assign a height to this thing of our size. That's going to be the intended size of our rectangles, and grab that. And then it's going to expand that as far as it can wide. Then we can segment the drawable area and create places to draw in there. We're going to want a few things here. Static float spacer. We're going to set that equal to like 4. Basically, the spacer is just going to be where we're drawing things. We need some space in between the different elements, so they're a little bit easier to distinguish. That spacer is what that's going to be. Yeah, I'm pretty sure this is everything. I could be totally crazy, but we're gonna go with it and see where we are. We also need a horizontal position is 0. All right. Basically, we're just going to draw one line, and then we're going to figure out the rest. That's sort of the intended plan here. So if we also need a GUI layout min width. We're going to add a min width here of our size, so we can guarantee that we're going to be able to draw at least one element per row. This is to handle if you shrink the width of the results too small. This would stop working. We need that in order to handle this, just so it grabs that and creates a scroll area. That's the best I think we can do. Otherwise, this would just infinitely loop, and we don't want that. Yeah, I think we're good. If the drawable area dot width is less than the size, then we need to do this again. Basically recreating everything. What this is doing is creating our next row. We also want GUI layout dot begin vertical. There. That just marks it as a vertical area. We're going to be drawing these control recs in a vertical slice, so each of the lines is drawn vertically, one on top of the other, we're going to be manually controlling what's drawn where inside of this. Just the best I can think of. So how do we want to do this? At the very end here, we want to take our horizontal position and increment the size plus the spacer. And we also want the drawable area equal to a new rect. Oh, how do I want to do this? Sure. I don't think we need the horizontal position. I'm going to get rid of that. That's not needed anymore. We're just going to rely on this rect that exists. I think that makes way more sense. This should accept like an X, Y, width, and height. Something like that. So yeah, X, Y, width, and height. Cool. From that, we should be able to do drawable area dot X plus the size plus the spacer. Drawable area dot Y, and the width minus the size minus the spacer, and the height. There we go. We actually need to reference that, but there we go. Let's make that a little bit easier to read. There. All right, so what this is doing is modifying our drawable area. Effectively, we're keeping the far boundary, I guess on this side, we're keeping this constant, and then we're just stepping further and further over each time we draw something. We need to reduce the width by the same size we move over on the X. That keeps our width, that keeps our, this side, okay, that keeps this side constant. It prevents it from moving. Without that, we would just constantly be shifting the same thing over and over and over and over and over again. And that doesn't work. That isn't what we want. I keep forgetting my camera is mirrored. Anyway, we have this. That's going to update our drawable area. That does it at the end of the thing. We already are testing if we have enough space to draw something. We do. So we need our drawn rect equals new rect drawable area.x, drawable area.y, and then size and size. So we're just passing in the sizes to use. This is defining the space that whatever our render is going to use is going to be provided. And so with that, we now need to actually render the thing. So we actually have our component like that. We do not have a way to actually draw this thing. The way that I'm getting the drawn object is using this result renderer selector, which we did not provide. We're just gonna pass that directly in, I think. But this catalogs all of the known renders. So this is only run once. That's part of the startup loop. That's why it takes so long at the beginning, is because it's actually crawling over your entire assembly to figure out what's there and get everything in order. This is part of the reason that's so slow the first time. Ideally, this happens as part of like starting up the tool. We're just not there yet. So the optimization of this entire tool has not happened yet. So there are certain things that are just very slow. And we'll get better when I have time to make them better. So let's just pass that in as the first thing. Our renderers. Sure. Let's do a renderers dot get the render. So basically, this is going to find the best renderer for a given type. The way this works is currently it's going to look for any type that can extend a result renderer's supported type. So if you have something that supports, I don't know, something. what do I have that would be inherited? I don't really have anything. Unity's objects. So if you extend Unity objects, that's pretty much any mono behavior. That's any of the other Unity things. If you have something that extends that, and also something that is specific to the type, it is going to take the thing specific to the type all the time. But if you do not have something, it has like a fallback of looking for anything that could potentially implement the supported type. That just gives you like the fallback ability. It also means you can support things like interfaces, things like that. Anyway, get result render. We need to get the result of the specific type. There's a lot of type references in this entire thing. That's just how it works. So let's. We need to do something else. Var result equals component dot get value. So we're going to get the value here of whatever the thing is we're using, and do that. Get the result render from the result type. Get type. So there's two things that the property knows about. It knows about what the containing type is. So in this case, if we're talking about like a position in a transform, it knows about the transform and has a reference to the transform, and it knows that we need to access that transform's position property. And so we actually want the type of the position, not the container type. So there's two different things. That's why we're getting the value first. So we're getting the result of whatever that type is, and then making a render for that type. And then, now that we have our render, like that, let's do something. Render grid, and we need to pass in our drawn rectangle is read only, which we do not know yet. So I'm just going to do result. Isn't this part of this? No, that's the result. Never mind. Component is read only. Is read only is for things that do not support writing. So for example, if you have a property and it only implements the getter, so this is a get only property, there's no way for us to do anything with this. So we have a is read only so that the renderers can handle this in a special way. If they want to display something that can't be written to differently, they can do that. It doesn't have to be implemented. If it's not implemented, we just cannot try to set the type because that will fail. So there we go. And then our value we're rendering. So there we go. That's our render. And then for this, we're going to get a value out. So var new value. There we go. If our component is read only, we need this to be a not read only. So if it can be set, then we need to set that. So result, not result, component dot set value, and we're going to set that to the new value. So this assigns the value if we were able to actually do that. Otherwise, it will just not try to assign the type. Read-only things are supported, but I feel like they're a lot more useful if you can actually edit things. It's just that there isn't always things that can be written to. I mentioned the fields, for example. If it's a value type, there's no real way for us to actually modify that. If we're just getting value types, we can change it internally and it will change, but that isn't actually useful for anything, because it's not going to actually affect the object. It's just going to affect whatever we're displaying, and that, okay, why? So there's no reason for us to do that. So this is a way to kind of prevent that and keep the UI as clean and clear as we can. I do have something to draw for is read only, but it doesn't work right now. Anyway, that is our grid renderer. This should automatically handle creating stacked components, so it should work. Maybe we'll see real soon. Why doesn't it like this? inconsistent accessibility. This should be internal. And so should this. Yeah. All right. There. Internal types are only accessible to the assembly they're part of. So in this case, internal types are accessible to my tool. And once I start, like, if I end up shipping like a binary, for example, they'd only be accessible inside of that binary, not to classes outside of it. It's one of the main accessibility things. There's a whole bunch now in C#. They added a few more recently. But yeah, anyway, there we go. Does that fix it? Oh, I had mentioned static classes and throwing errors. This is one. We didn't make this static, so we were getting an error. There we go. That makes it work, hopefully. LINQ for Unity editor window. Cool. All right. Now comes the fun part. We need to render this. Not in here. Execution result component is what renders the results. It is basically an encapsulation of a specific result. So if we look back here, each of these blocks is an execution result component. It's sort of the container that handles showing you the results, getting all of that rendering stuff done, doing everything that you need in order to actually see what is happening with the thing. What we're going to do is loop through every single result and sort them into list objects, things that need to be rendered as a list, and things that need to be rendered as a grid. Because they can both occur at the same time, then we'll need to do probably grid first and then the list render after that, just to actually make this work. This is another annoying issue. We get this error. You can't see it, but there's a error copying in assembly. You might be able to see a little bit of red down here. Anyway, basically there's some weird issue with Unity's copying. It compiles its libraries into some temporary directory and then copies them over the existing binaries. That fails occasionally in this version of Unity. And so what that's causing is all of my changes did not get imported. I'm still running the old version of the code. So all that code we just wrote actually isn't here. We actually need to restart Unity in order to get that. But yeah, anyway, this entire component is an execution result. Yeah, that's that. One sec. All right, while Unity is restarting, let's just jump in here and implement the correct rendering behavior that we want. It all happens in this render thing. We get a LINQ command. The LINQ command is the command you issue and has the results for you. We need to parse all of that. So let's do that just up here. I guess we can just do it here. For now, this is not final. This probably won't ship. But we can actually just get list renders, list results. Sure. Let's do command dot result dot where. Oh, we're gonna need to actually pull out. Oh, this is gonna be weird. Because it's based on the value. I guess theoretically, there would be a case where you could actually switch the type of something. Because if we're working with like an abstract type, theoretically you could change the entire type. So let's say we select all the Unity objects in a scene. For whatever reason, we do that. If we switch something from a capsule collider into a mesh, I don't know if that's a thing you could do, but if we did that, it would change what the thing was, whether it's a grid or a list. That could be weird. I don't think we need to worry about that, so we're not going to. But let's do R for result, and we need to get the renderer from this. So let's grab the selector, get result render, get value. Again, all of this is temporary. This is just to get us past this point, because we need this to actually do anything. So r.getValue, perfect. Dot renderer type is equal to list. So if this is a list render type, why? Oh. All right. So this function is gross. It's very long and very, very awful. But it should work. What we're doing here is grabbing all of the things that should be rendered with a list by finding what the value is, getting the renderer for that value, and then sorting it by the things that are lists. We need to do the same thing for grids. Cool. Great. That's a thing. Okay, to list. We're going to, if you're unfamiliar with LINQ, these toList, toArray functions are intended to sort of be completions of whatever your query is. LINQ is lazily evaluated, which means that it's going to be evaluated whenever you request this. The results are a reference type, which means that every time you run this, it's going to rerun your entire query from scratch. So every single time we referenced the list results without that toList function, it was going to requery all of our renders, get the values, get the types, and do all that stuff. And no thanks. We don't want to do that. So this is going to evaluate that once and then save those results into a list for us, and that's the results we get. Usually a good idea if you're using LINQ, because otherwise it can be very easy to reference the type later and end up doing your query again, especially if you're doing like sorts or you're working with a large data set. That's typically not great. So should be enough. That should do everything. This is all doing like the actual like query and things like that. Some extra buttons for UI stuff. For each result in our command that result. This is going through and grabbing the results. We don't want that anymore. We actually want the list results. Cool. That's going to draw our list. And then we want our grid view dot draw grid results with our selector, and we need to provide a draw list with the grid results and the size. Let's do 160. So 160 pixels high by however wide, and it should just try to fill that as best as it can. And we should be able to test this by resizing our Unity thing. But okay, that's still loading weird. Anyway, hopefully that works. Hopefully that does what we think it's going to and draws the grid results and gets us our thing. We can't test that because Unity hasn't started. Oh, there it is. All right, cool. So this should, if this has worked, give us a grid view. We don't actually have anything implementing that yet, so let's go and do that. Let's grab our meshes and make this a grid result render. Let's implement that. And we're just going to do this. For now, we're just going to return the value. Sure. And comment that out because I actually want to keep some of that. Like the object field is what you actually use to change the mesh. So we actually want to keep that around, but not for now. All this is doing is grabbing the editor and rendering it. There's some weird things happening in this code. It looks like it's not very much code, but there's actually some fun things going on with the model inspector. This type is internal to Unity, so we can't actually access it. That creates a bunch of problems if we actually try to create an editor for it. When we create an editor, Unity actually, in order to render its object previews actually creates a sample scene. You don't really see that. You don't get a new scene object created for you, but there's a sample scene in Unity's editor that is used to render these things. The downside is every time you create an editor, it's going to create a new sample scene for that editor. And so this is invoked every single update, which what was happening is we were creating hundreds of sample scenes and slowing Unity down and causing a whole bunch of problems and breaking everything. This uses the cached editor, so it reuses the same one, but we can't access the type because it's internal. So there's no way we can create copies of a model inspector by creating an inspector or an editor for a model, a mesh, but we couldn't actually cache it or access the type at all. And we need that in order to be able to actually properly handle the lifecycle of that inspector. So we're doing some reflection to get it. I'm hoping we can get rid of this eventually, but right now this is our solution. This is gross. We don't want to do this, but we're doing it. Anyway, on preview, GUI is going to render the preview. That's what we need. It already takes an area, so everything should be good. This should just work. But it might not. Who knows? Everything might explode in my face. That's fine. Everything reloads. In a live stream, we implemented history. That's what this is. So this list is all the previous commands we've run. It's kind of janky right now. It doesn't work for like multi-line commands, which are supported, but this breaks them. Basically, it's a list of all the previous commands you've run. There's no results here. We can't expand this. But these are just commands that we've run, and there's a rerun command here, so we can just rerun our shared mesh query and get these. And it works. That was unexpected. There's some weirdness. It's kind of tall, and I'm not sure why, but it works, which is more than I was expecting. That's actually kind of cool. I didn't expect that to work. I don't know why it's so tall though. We might. So this is something new that I don't know how to use, but this is the visual element debugger Unity provides. It actually lets you look at a UI that it's doing. Let's pick an element. Oh, that didn't really seem to do what I wanted. I've never used this, so we may abandon this option very quickly. I would like to access that, but I can't. Yeah, this is going great. So if we expand this, maybe I'm confused because I've used this in the past, and what I've been able to do is see like the tree that it's rendering, but I can't. So never mind. I don't really know what's going on here. This is obviously too big. Also, oh, that's what's happening. All right, we're gonna cheat the system. We're gonna make this really big. So I want to make sure that it actually wraps. And this will also give us some other fun results. So let's make this 600. So that's going to be a very, very, very large mesh. Obviously too big for useful results here, but will be kind of helpful. Also, because Unity re-renders everything, you actually lose your ability to work with this. Does this? Oh, cool. So it just automatically wraps it when you have enough space. Okay, so that just works. That's nice. That's kind of neat. We can scroll down here. We still have an extra like UI element. Like this almost seems like a fixed width. Because even when it was 160, was that what we were using? It was still that same size. I'm wondering if there's something we're doing here. I don't think so. Oh, that might be it. We might be creating an extra set of elements because we can. If the width is less than the size, no, that seems fine. Because this will create the drawable area, recreate that, give us a new space. Yeah, that seems fine. I'm not sure. Something is causing us to get this big extra space. That might be something for like a live stream or something to figure out. We don't need to solve that here. But this is our grid renderer. We actually did it in a fairly decent amount of time. It's only been 50 minutes or so, and that's honestly much better than I was anticipating. But this actually seems like a much more useful way to do this. There is one thing that I do want to add though, and that is the selection component. You should be able to select individual objects, and right now you can't even tell what these are. So you can't tell what they're attached to, anything about them, things like that. We want to enable that. So 2 things. Inside this mesh sampler, we want to draw our object feed. Object rect equals new rect 0 or area dot x. Sure. Size is going to be something else. Why is that? Anyway, y is going to be area.y. It's basically taking the top. I think this is the top. We'll figure that out real quick. And the width is going to be area.width. And then the height is going to be like 24. We can get the actual height. But what we want is editor GUI object field. So because we're not using the layout, we actually need to give it a rectangle. That's what we're defining there. And so if we give this the object rect and the value, our new value equals value, or just value, yeah, there. Oh, we need to give it the type of mesh. There we go. And we need to convert this back as mesh. Basically, I'm just copying what's down here. And I think that should be good enough. Apparently, it's much more different than I was anticipating. That's unfortunate. We may not get this to work. Oh. What? Why are they? Okay. Weird. They're backwards for whatever reason. There. Cool. This might be deprecated. Allow scene objects. True. Cool. There, done. Scene objects is going to allow you to select objects from your scene as part of this field. Anyway, there's our value. That gives us a way to edit this. It should either appear at the top or the bottom, one of the two. We'll figure that out once we figure out what the Y is. Some things draw in graphics, some things draw from the bottom, where Y is 0 at the bottom of your screen. Other things, Y0 is the top of your screen. It changes depending on platform, I believe. I don't know which it is, so we're gonna figure it out. I imagine it's the top, but I could be wrong. That makes the most sense to me. Anyway, that wasn't what we wanted to do. That was just a side thing. What we wanted was in here. I have this massive thing. Alignment equals alignment. Cool. So this whole block of code is used to render that button on the left side of lists. And it gives you a icon for what the object is. So Unity has icons for like game objects and transforms and things like that. This gives you that icon so you have a little bit of a visual indication of what's going on. It also is useful for actually selecting things. So if you click the button, it's going to add it to your selection. If you hold shift, it's going to add to your current selection. If you just click it, it's going to overwrite your current selection with whatever the new thing is. But we need to draw that with private static float. Selector height is 24. Eventually, all of these like hard-coded values are going to end up in one space, but we're not there yet. So we're making it up as we go. Height, size plus selector height. Cool. Height plus selector height. Eventually, we can clean up some of this too, but it's fine. I'm more reassuring myself than anybody else. But there we go. Drawn rectangle is that. There. Ooh, that's gross. All right. X, Y, size, and size. That's fine. We need to move the Y down by the selector height. And that's effectively going to shift everything down for this, our drawn render. And effectively, we're just making it 24 pixels taller than it is wide for each object. And that should give us enough space to hopefully selector rect. There we go. Trouble.x, selector height. Cool. And the size, the height is the selector height. There we go. Component, we called this the component and we called it result in the previous thing. That's kind of confusing, but we're just gonna replace all of that. Weird. That's weird. I'm gonna ignore it. Anyway, there we go. Button, cool. Width, height. Width can be equal to the size. And I don't actually need any of that. We're just gonna do GUI.button at our selector rect. There we go. With our UI content. So we're using the GUI content object to store things. This is useful for storing like tooltips and text and icons in your buttons. You can just provide a string, but then you only get a string. We actually want an icon and some tooltips, so that's what we're doing. The tooltips are useful if you have an object with a name that is longer than fits in the button. It will be cut off and truncated. This gives you a way to actually see the whole thing. So here we go. All of this is just for selecting things. Hopefully that works. And I'll figure out this extra space stuff later. But if I've done this correctly, you should be able to rerun this. And now we actually have selectable things. It got even taller. That's not a good sign. I need to fix that. But by clicking capsule, we can select it. If I hold shift and click the cube, we now add the cube. These things are effectively selectable now. And hopefully that just makes it all much simpler. That's pretty much everything. That was a little bit extra, but that was everything that I wanted to do here. Still some bugs, but I think this is a good step. I think this actually improves things significantly. There's a lot more to experiment with, and I'll continue working on that. But if you have suggestions for this, or this is something that is interesting, let me know in the comments. I think this is a really useful tool. So I'm pretty excited about it, but I don't know what everybody else thinks. So if you like it, let me know, and I'll make more videos on it. A lot of this has been work that I've done off camera, just sort of whenever I have time or whatever. But I can definitely make more videos on it if it's interesting. There's a lot of weird reflection-y stuff going on to make all this happen. But I think it's cool. Anyway, if you really want to catch more of this, a lot of this, because it's more long form, ends up on Twitch. I'm trying to do more and more live streams to kind of capture some of this more longer based content. And Twitch is a pretty good place for that. So there'll be a link in the description to my Twitch channel. You can go and follow us there, and hopefully join in and see some cool things. But yeah, that's pretty much it for now. So hopefully this is interesting. Hopefully it's cool. If there's other things you want me to cover, or just want to see, leave a comment and I will do my best to cover them. I have some really cool things in the works. So yeah, that's it for now. So I hope you're all having a great evening or morning or whenever it is. And I will see you in the next one. So until then, see you, Internet.